Okay. So for the first one, it says define acceleration. So you just need to write.
So you aren't sharing your screen.
Okay, sorry. Do that in a second. Is it visible now?
It is.
Okay. Change in velocity per unit time. You can also write rate of change in velocity. That's fine. You can also write the formula. That's fine. Okay. Describe the motion cyclist in time between 0 and 15. So it's, you see the gradient is going up, which means it is accelerating or increasing speed. Then 15 to 30.
So can you write that it's accelerating at an increasing rate?
Accelerating at an increasing rate? No. You don't know that. You can only write increasing speed or accelerating.
But if it's like a happy curve, isn't that at an increasing rate?
Increasing rate, yes, you can write it when you have velocity time graph and it is showing you like this. You can say accelerating at an increasing rate.
Okay.
But not in this, because in this graph doesn't show you acceleration at all. All right, it just shows you increasing speed, and we can reduce that it's accelerating. That's all. Okay. Now this is constant speed because it's a straight line. Then the next section 30, it is a decreasing speed. Now you can write decreasing speed or deceleration. Just deceleration, do not elaborate it. Now the average speed for 40 seconds. So you go here, it's 300 divided by 40. 15, 7.5 meters per second. So please make sure you write the correct units. Maximum speed. Maximum speed would be where you have the greatest like slope, and that would be here. So now what you need to do is you need to take the gradient. So one of your points here is 30 to 50, and here it is 15 and 60, 70. Now what you do? Take gradient. 250 minus 70 divided by 30 minus 15. And this gives me 12 meters per second. Okay, so I'm going to write 12 meters per second. Now, the next one says state one advantage, disadvantage of using a turbine. Advantage basically is that it does not produce any harmful gases, right? But the disadvantage is that it's like unreliable, as wind is not always blowing, and it is also expensive to build. Like there are a couple of things. You can also talk about birds, that it can, disturb ecosystem of the birds, but that's fine. Okay. Yes.
For advantage, can you write it sustainable?
It is sustainable. Yeah. Sustainable, if you mean by, you're equating it to renewable, then that's fine. Okay. Then the wind goes at speed of 16 towards the turbine blades. In 1 second, a volume of this air passes circular area. Density this. The mass of the air that passes through circular area stepped out by 1 second. Okay. Says what is the mass? So you have the volume in 1 second, you have the density. So density is mass over volume. And now 1.3 times 2400 like 1000. That would be 31200 kg. Wow. That's a lot of air. Okay, the kinetic energy of mass of air that passes through the air served by blades. Now, kinetic energy formula is Walaikum Assalam. Who is this and who's late?
Sorry,
Shafa.
I'm late.
All right. Now, half mv square. So now you have the mass. Also, you got the speed. To do that. Now, sometimes it could happen, with the best of us, that our first part may be wrong or we just didn't understand how to get it. So do not worry, my friends. What you do, write a dummy value here and then use the value in the next part that it will still give you at least marks for error carried forward, which is a great thing. All right. Do not leave any part unattended. Please. Suggest why some of the kinetic energy of the air passes through a circular area. Circular plates is not converting to electrical energy. That is because that there could be friction between moving parts. So some work is done there as well. You could say that not all air is hitting 90 degrees to blades. That could also affect that. You can say air has different speed. You can also say that some air is still blowing, so not 100% of speed converts to electrical. So air can't just stop. That's fine. Okay, if you have any questions, please let me know. All right, object is moving straight line constantly. Straight 3 ways which force may change the. Okay, so force can do 3 things. I mean, it can do a lot of things, but mainly like 3 things. I'll tell you what. Number 1, it can definitely accelerate something. When you say accelerate, I mean you can increase the speed. It can also decrease the speed, So it can decelerate something and it can change direction. So this is 2 things a force can do with related to that. Okay, so now we have this and they say state the scale of use. So now if you look at it, there's 360 newtons and 45 degree, and says by drawing space below, determine the tension T of the vector. Okay. So now this is something I just want to tell you, this is important. So if I could find the resultant of these two, that resultant should be equal to the weight that is right here. So I'm going to put a dot here. If I were you, I would draw a dotted line, horizontal dotted line first before starting this question. Okay, and I want it down. I don't want it to up. Okay. Once I have the horizontal line, for reference, I would just mark 1 point. I would put my protractor and then measure 45 degrees and then extend the line according to my scale. Now let's take scale, because this is 360 newtons, right? How about we take like scale 1 centimeter equals to 60 newtons, right? If I do that, then basically, wait a second. All right, so basically its resultant should be 360, right? So what you do, this is not good. Okay, let me tell you how to do this. So first I will draw a straight line of, say, something like this, and it should be 360 newtons, and 360 newtons should be equal to, according to my scale, like 6 centimeters. Okay, so this is 6 centimeters. Then what you do, you basically pick any vector like t, put the protractor, use 45, and just extend this line. And this line should be extended till you feel wherever, doesn't really matter. Okay, because we are looking for, we have the resultant, we need to look at the original force. And then what you do is that, yeah, you can measure 45 again. You can put the protractor right on this side like this, measure, sorry, like this, and measure 45 degrees, and then extend this like this. Okay, wherever it is. Now, wherever they intersect, this means that this is the point, this will be t, this will be, I mean, this is the t, and this is the other t. You can measure it using your ruler, whatever the length is, and then you can convert it into scale, and then you can write it. Okay, so this will give you, this is particularly one of the harder ones that I've seen. However, there is one easy step for this too. If you like, you can do that too. Basically, what you do is that you can make bisector at 45 degree, and then you can do it. But the thing is that the only reason I'm telling you to do head to tail rule here is because wherever these two intersect, that would actually make it much easier for you, and you can start from anywhere with respect to that. So let me check the mark scheme, what they have given. Okay, so if your answer is between 250 to 260 newtons, that is ideal. Okay, so please make sure you have drawn that. Okay, acha, I hope that's clear. Okay, then
Okay.
yes,
For the above question, can we write change shape? No, third A part.
change shape. Well, force can change shape.
We can?
I think we can, but it's not talking about shape. It's talking about motion of an object, so you can't write it. It's only talking. He has restricted us, so bad news. Okay, one more thing I was thinking here was, if we could just, we could also, instead of, taking this thing, we could just randomly draw a horizontal line for reference, and then we mark like 45 degrees, and then we extend, let's suppose we extend this to 3 centimeter. Then we know that the other t is also 45 degrees, we measure and we extend it to 3 centimeter, right? Now, what we can do is we can play like the anti thingy with this. Let me tell you why. Okay, once you both the things, you can then again, make parallel lines. You can make 45 degrees, put the protractor 45 degrees and 45 degrees. Once you have this, now you know that your resultant is going to be from this point onto this point. So you measure your resultant, right? And maybe it comes out to be some other value, right? So of course it will be. So let's suppose that it comes out to be some value. You say, okay, if if let's suppose you say, okay, this comes out to be 7 centimeters, you say, okay, 7 centimeters represents 360 newtons. So whatever you've taken, 3 centimeter would represent what? And then you can take this scale or whatever and write it here as well. This will also give you the right answer. So whatever you like, whatever is easy for you, you can draw it. It's fine. All right, then. In this question, it says what is contained in the space that's always vacuum. Right? Calculate the value of H. Okay, so it basically mercury barometer gives you atmospheric pressure. So we're going to write. Oh. Let's do this. 1.02 times 10 raised to power 5 divided by this divided by 10. So that is 0.75 meters, by the way. And then it says the tube containing mercury is now tilted so that it makes an angle theta with vertical. After tilting, this continues to be space above the mercury in the tube. State extent whether the vertical height of the tube is smaller, the same, greater, it will be the same. The reason for that is that atmospheric pressure is same, so it shouldn't change the column height. Atmospheric pressure will be same since pressure is rho gh. It does not depend on angle, only the height. So let's suppose if you put it like this and somewhere you put it like this. So oops, my tube is smaller. So it will still show you mercury tilted. It doesn't really matter, right? So you have to remember that the tube always works like this, all right? No matter which angle it is, doesn't matter. All right, then another mercury barometer in the same room at the same time shows a lower value H than barometer. Suggested the reason for lower value. The lower value is always because there is less pressure, less atmospheric pressure. In the room. And this is because the temperature of the room is lower. Also, sometimes air gets inside this. Sometimes it's not completely vacuum, so that also pressurizes it. So that's one thing you can also write. Then it says state the value of fixed points of thermometer scale. So 0 degree Celsius and 100 degrees Celsius, upper fixed and lower fixed. Okay. Now,
Right?
yes.
For question number 4, B part, it says it is in the same room.
It is at the same room? Oh,
Mm.
then this answer is not correct. This means that some air, I thought they're different, might have escaped into the portion above, okay? And now it is exerting pressure down. Is it clear? You can write this then. Okay, should I go on now?
Yeah.
Okay. The graduation liquid glass thermometer equally spaced. For this equally spaced graduation, assumption that is made about the liquid of thermometer. It is always assumed for a linear thermometer that it has uniform or linear expansion. Okay, assumption that is made about the structure of thermometer. Okay, well, it means that the thermometer bore is constant, has constant or uniform thickness or diameter, whatever you want. Okay. Liquid and glass thermometer A has a greater range than B. So that's one way the design thermometer is different. Maybe A has longer stem. That could be, one of the reasons. Another reason could be that liquid in A expands less actually, so that it has larger range, right? So, and there are other reasons as well. Now, liquid and glass thermometers C has a greater sensitivity than D. State 1 design is different. To increase the sensitivity, you need to have a larger bulb. So C has larger bulb, or it could have a thinner capillary tube. That could be one of the reasons. And also it contains some liquid, or like liquid in it has greater expansion. So these are all the reasons that really, give space to having greater, say, sensitivity. So you can write it if that's wrong. In the space provided, draw thermocouples. Thermocouple is very easy. What you do, you make two buckets. One wire like this, the other wire like this, and a voltmeter right here. One is the cold junction. One is the hot junction, always. And always write two different names of the wire. Like it could be material, iron, it could be brass, copper, or whatever you want to write. It's fun. So it should be different. Okay. Then it says suggest with thermocouple be more suitable than liquid. When a thermocouple, it is very suitable when there is very high or very low. Yes, the same page.
Yeah.
Okay, you can also label voltmeter. I forgot. You can add amp meter. You can also add manometer. All of them work. Okay. So if there is very high or very low temperature, also if there is very rapidly changing temperatures. All right, now electric heater is placed on the floor of a house. The heater is switched on. The state main purpose is thermal energy. It has to be convection, because heater will heat the cold air down. It will become less tense. It will go up. And blah, 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 blah. Okay. The heater has a power of this. The air in the room has a mass. This the specific heat. Calculate the time takes. Okay. So Q equals to MC delta T. The power, energy is power into time equals to MC delta T. 1.5 times 10 raised to 3. Time is T. Mass is 65 720. Change in temperature is 15 minus 8. So what you do? Solve it. 65 times 720 times 15 minus 8 is 7, I think. Divided by. So it's 218, almost 220 seconds it would take. Okay. All right. Now, it says state 2 reasons why the time calculated in B is smaller than the actual time taken to raise the temperature. So it's saying why would it take more time? So you could write floors. Floors may, conduct heat. So that would one of the things. Also, there could be like cold air entering from doors or windows, right? Could be that. So that's something here. Okay, then going to the next one, it says complete the following by writing solid liquid. State X from solid to liquid. This is very easy. State Y from liquid to gas. Explain in terms of forces between molecules why gases expand more than solids when they undergo same rise. The reason for that is that you guys need to understand that intermolecular forces between gas particles are almost negligible. Negligible means that even if you don't consider them, they don't really matter. So, with little energy, they can move farther apart quickly. So that should be written. Now, a slender volume, this contains a compressed mass. The valve is open, capacity is blah. The temperature does not change. Calculate the volume escaped. Volume that escaped gas occupies at the atmosphere. Okay. So P1 V1 equals to P2 V2 is your best friend here, as you already know. The first pressure was 1.8 times 10 raised to 6 times 0.012 meters. The new pressure is, and the new volume is, gotta calculate it. Why haven't you guys calculated anything? Are you guys even doing papers? That's not good if you're not. Okay, so it is 0.216, right? 0.216. Now you need to understand how much, it says how much gas escaped. So this should be the volume. And now the escaped gas should be the one that's basically 216 minus 0.012. So we got to find 216 minus 0.012. So that should be about 0.204 meter cube has escaped, by the way. Now, this, it says draw the wavefronts of the wave. Now, this is a very important question because when this happens, right? Always first draw the straight line like this till here. Okay, so this is the incident wave. And then draw a normal line. What is a normal line? If you don't know, normal line is a line that is 90 degrees to the surface, right? So when you draw the normal line, now you see ice is more dense than air, which means that this wave is going to refract away from the normal. Well, it can't refract that much, but let's keep it like this. Okay. So then you draw the direction of refraction, and let's say make the wave fronts, right? So what you do? Wave fronts are always 90 degrees to the 90 degrees to the direction of waves. So basically you make parallel lines from all directions. You can either do this or you can just continue making equal wavelength parallel lines like this. So make sure you do that. If you have any questions, please let me know. Okay, calculate the speed of light. Speed of light in ice. Now, because you have refractive index, I just like to tell you that refractive index, when it is going from more dense to less dense, is 1 upon n, and then it is like speed of light over the speed of wave. So we want to find the speed of light wave, and that would be basically c times n. Wait a second. Is that even correct? Yeah, it is correct. No, sorry, it has to be n. It's wrong. Okay, so this will be c upon n. Now c is 3.0 times 10 raised to 8, and n is 1.3. So what you do? And it is 2.31 times 10 raised to 8 meters per second. Yes, any questions, please? Anything you guys want to ask? Everything is clear? Okay. So who's missing today? On is here. Right. Okay. Now, going to question number 9. Calculate the resistance of the thermistor when potential difference across is 7. So we want to find the resistance. So at 7, you go right here and then check right here. It is 1, 2, and 3. So I think it's 4.2 and 4.2, 4.4, 4.6. That's 4.6. So you have the current. Now you use V is equal to IR. Current is 4.6 and you find resistance. That is about 1.52 ohms. Then it says on table, tick the boxes that indicate the effect of resistances of the resistor and of thermistor. So it says tick the box to indicate the effect of resistor as the potential 0 to. As you can see, the thermistor is allowing more current. Like it is letting the resistor is staying constant. So basically, that means that resistor is constant and resistance decreasing for thermistor, which is something you should write. Okay. Now, it says thermistor and resistor are connected parallel 7. Calculate the current. So at 7, they both have the same current, 4.6. So basically, if they're parallel means that their current must be added together. That is 9.2 ampere. Then say the energy transfer supply in 5 minutes. So power is equal to VI, energy is equal to VIT. sorry. So we have 7 as voltage, current is 9.2, and the time is 5 minutes and 60 seconds. That is 1.9 times 10 raised to 4 joules. That should be the answer. Yes, please, if you have any questions, let me know. Okay. Same video. Now, the electrical energy produced by power station is transmitted over long distance high voltage. Explain why high voltage is used. Now, it has a very set answer. Please let me know. Let me tell you. First, you say power is equal to VI. Then you say, since at high voltage, for equal power, current is low. Okay, you write it. Then lower current means less heating during transmission. Transmission means when electricity is transmitted from one to another, right? So it reduces the cost and power losses. Is it clear, everybody? Okay. Then in this one, it says primary coil is 4,000, input is 120, secondary coil is 9, calculate number of turns. So for this one, voltage in primary over voltage in secondary equals to number of turns in primary over number of turns secondary. You should remember this. 120 divided by 120 divided by Vs, 4,000 over Ns. This is 9, by the way. So Ns would be 9,000 times 9 divided by 120. So that is 675 turns, right? Now, what is a suitable material core of transformer? Always write iron, because it is a temporary magnet, temporary core magnet. Okay, then this is my favorite. So there is iridium and this, I don't know, platinum, okay, and beta. So you should remember beta is 0 minus 1. And then you add this row, 194 equals to x plus 0, so 194. 77 equals to this minus 1. So this should be 78. Then it's balances, right? Then half-life of iridium is 19 hours. A sample of iridium has initial count rate this. Calculate a count rate 38. Now, I just want to tell you, first of all, we're going to divide 38 by 90. I think it should be 2. Yeah, so you have 2 half-lives. 2 half-lives mean that you have to divide this by 2 twice. 110 times half and times half. So once you do it twice, you're good to go. So it is 275. And voila. So easy. Oh no, it is counts per minute, not becquerels. Please write the rates, correct units.
Okay.
And yes.
Can the half-life be in decimal place? Is it possible?
Half-life will be in decimal?
No, is it possible?
No, not in your course right now. It is possible. But
Maybe the
in
A
it,
levels one?
yes, yes.
Okay.
State two ways in which gamma emission differs from beta. There's so many ways. All right. This is uncharged. Gamma is uncharged. Gamma does not deflect in electrical or magnetic field. I'm writing many, so you guys. It has very high penetration. What else is gamma all about? It's about cannot be fully stopped. But reduced by lead. It is electromagnetic radiation. Okay, what else about it? No mass. And I think that's it. For beta, it says two ways which beta differs from beta. Can be even write that beta is fast moving electron. Beta is negatively charged. Beta has mass, can be deflected by electrical and magnetic field. It has low range. It is stopped by aluminum. What else? It is it can ionize. Moderately ionize as well. So things like this. So you can write anything you like. Okay. For 2 marks. And I guess that would be it. Yay. Tell me. Do you have any questions now?